Okay, I'm going to begin chapter 11 now. Chapter 11 is a chapter all about functions, and of course we've mixed in things with function notation and working with functions already. So 11.1 is just a kind of a review of that stuff. Remember that a function is a rule that takes an input value and assigns one and only one output value to it. For each x, there's only one y. Okay. The domain of the function is the set of all input values, or the x values, and the range of the function is the set of all output values, okay, or the y values. Let's take a look at problem 1. Here are the names and birth dates of 5 individuals. Does a function exist for which the input value is the name of the individual and the output value is the birth date of that individual? If a function does exist, right, yes, and state the domain of the range, or if not, then explain why not. Okay, so does each x go to one y? Well, you'll notice here that Emily and Marcy have, or Marie have the same birthday. That's okay. Each individual has one birthday, right? Nobody can have 2 different birthdays. That's not possible. So the fact that they share a birthday, yeah, that's fine. There's no problem with that. Each x goes to one y. So yes, this is a function. The domain would be the set of input values, or in this problem it'd be the names there, and the range would be the set of output values, which would be the corresponding dates listed. Okay, so here's another one. Problem 2. Here are the names and ages of 5 members in a study group. Part A. Does a function exist for which the input value is the name of the member of the study group and the output is the age of the person? A function will exist. In other words, each person only has one age, right? We didn't really need a table, but to make that statement, right? Each person has one age. You can't have an age of 19 and also an age of 24 or something like that, okay? So a function does exist. The domain would be the set of names listed, and the range would be the set of ages, okay? Part B, does a function exist for which the input value is the age of a member of the study group and the output value is the name of the person? No. A function would not exist here in that situation because you can have lots of people that are age 19, for example. Okay, 19 is Rebecca's age, and 19 is also Madeline's age. So for each x, you don't have one y, right? So I said no, since 19 has 2 outputs, or 2 y values, that would be the 2 names there. For each input, there can only be one output. Okay, problem 3, the set S, which is given there, is that a function? No, that's not going to be a function because for each x, there isn't exactly one y. 9 is going to -3 and 9 is going to +3. And you can't have that for functions. For each x, there can only be one y, not 2 different y values. Okay, the vertical line test is helpful in determining if a graph is a function. It says if every vertical line intersects a graph and at most one point, then the graph is a function. Okay, so problem 4, use the vertical line test to determine whether the graph is a function. Well, yeah, we're going to have a function here. In other words, if I draw a vertical line anywhere, I will only intersect the curve and at most one point. Okay, now in problem 5, we do not have a function. Okay, because if I draw a vertical line, like right here, for example, you're going to intersect the curve in more than one point. Okay, so for each x, there is not just one y. Like here's a y value up here and a y value down here. Okay, but for this problem, for each x, there's only one y. You could still fit in the rule there that we've been using on the previous page. right? Now, of course, when we work with a graph of a function, we want to be sure that we have a function, right? We want to be sure that we have drawn something that will pass the vertical line test, okay? I see more than I should where a student is working with a function, supposedly, and they draw something that fails that test, okay? Well, I know right away that their graph is wrong because they haven't drawn something that represents a function. Okay, so you got to make sure that the curve passes the vertical line test if you're working with functions. Next thing is just some practice with calculations here with functions. Problem 6, let f of x be equal to x squared minus 3x minus 20. Find f of negative 5. Okay, so that just means plug in negative 5 where we see x and then simplify. So I've done that. Negative 5 squared is 25. I'm subtracting a negative, so negative 3 times negative 5 is 15. And then minus 20, okay. 40 minus 20 is the output there. Find f of negative x. Well, just as in part A, where I was replacing x with a negative 5, I'm going to replace x with a negative x. Be sure that you include parentheses around the negative x's, since negative x squared, that's the same as x squared. You'll be adding 3x and then subtracting 20. And of course, simplify as far as you can go with these things. Negative f of x. Now that's different from f of negative x, because negative f of x means we want negative the whole thing for x squared minus 3x minus 20. Be sure that you have parentheses around the function, since you'll want to distribute the negative into these three terms. Okay, and so that's what I've done on the next line there. Now, just an observation. Notice how my answers for parts B and C are different. Okay, the signs are different. That shouldn't surprise me. I'm doing two different operations here. You know, one calculation is where I'm replacing x with a negative x. The other calculation is where I'm throwing a negative in front of the function. Okay, now sometimes these do end up being the same thing. When that happens, the function is a special function that we call an odd function. Okay, you'll learn about even and odd functions in college algebra, but the point is just to, you know, say that we're doing two different things here in these calculations. Okay, problem 7, we have f of x equals 7x minus 5. Part A, find f of 4/7. So that's just plug it in and simplify, right? Okay, 7 times 4/7, the 7's cancel, leave you with 4. 4 minus 5 is negative 1. Part B, find f of 3a plus 2. Well, where I see x, I'll replace that with 3a plus 2. Okay, if I distribute the 7 there into these two terms, I'll have 21a plus 14 minus 5, or 21a plus 9 would be my answer there. Part C, find f of x plus f of 4/7. What does that mean? Well, f of x is given to us here. That's 7x minus 5. F of 4/7, I've already found that. That's a negative 1. So all we're saying here is take the function that was given and then add negative 1. Okay, well, if I add negative 1, combine these two terms at the end, 7x minus 6 would be my answer there. Okay, problem 8. So there's a couple of problems in the book where you'll be doing some things with the graph of a function. By the way, in problem 8, I do have a function, right? I have something that will pass the vertical line test. So we're calling this f of x. We want to find f of negative 1. Negative 1 is my x value. F of negative 1 would be the y value. So in this problem, they're saying figure out the point that would be on this graph when x is negative 1, and then pick off the y value. Okay, so if x is, so like here's negative 1, negative 3 on the graph. X would be negative 1 in that point. Y would be negative 3, so therefore f of negative 1, that's negative 3. Part B, find f of 2. Okay, so what point on the graph has a x coordinate of 2? Whatever that is, the y coordinate is going to be our answer. Okay, well here's 2, 0 on the graph, right? X is 2, so y would be 0 there. Determine the intercepts. Well, that point that I just mentioned, 2, 0, that's an intercept, right? An intercept is any point where the curve crosses or touches the x or y axes. So here's 2, 0. Also 0, 0 would be another intercept. Okay, part D, state the domain and the range. The domain is all the x values. So I'm plugging in 2 numbers here. What are all the values that I can plug in? Well, in the situation where we have a graph, I would just simply scan the x-axis and look above and below. If I'm on the graph, I'm in the domain. If I'm not on the graph, I'm not in the domain. Well, here it's not going to matter where you're at on the x-axis. You can be anywhere and look above or below, and you'll be somewhere on this parabola. Okay, the parabola is heading downward and outward on both ends. It's going to cover the entire x-axis there. The domain, therefore, would be all real numbers. Okay, how about the range? Well, the range, we're talking about the y values. So in this picture, I would scan the y-axis, look to the left and to the right, and if you're on the graph, you're in the range. If you're not on the graph, you're not in the range. It looks like if we are at 1 or less on the y-axis, and we look to the left or to the right, we're going to be on this graph here. If I'm bigger than 1 on the y-axis and I look to the left and the right, there's no graph up here. Okay. Negative infinity to 1, you make sure that you include 1 there. Okay, since 1, 1 is on the graph, that'd be the vertex, right? So that'd be kind of like my start point here when I scan the y-axis. Okay, and here's one more in this section. So I have the graph of a function. Again, I have something that will pass the vertical line test. Now this is a half of a parabola on its side. We'll be doing some things with that later in the chapter. Okay. Of course, if I had a complete parabola facing to the right or to the left, it would not be a function because it would fail the vertical line test, right? That was this example right here. A parabola opening up or down, there's no problem there. But okay, so I've got a half of a parabola. Find f of 5. Well, here's 5, 2 on the graph, right? X is 5. Y would be 2, so f of 5 is 2. Part B, find f of 0. Okay, well here's 0, 1 on the graph. X is 0. Y is 1, so f of 0 would be 1. 0, 1, that's an intercept. Okay, here's negative 3, 0, that'd be another intercept. Those 2 points are the only points where this curve is going to cross or touch the coordinate axes. And then part D, state the domain and the range. Okay, so the domain is the x values. If I scan the x-axis, it looks like if I am at negative 4 or bigger on the x-axis and I look above or below, I'm going to be on this curve here. If I am less than negative 4 and I look above or below, there's no graph over here, right? Less than negative 4. So I'm going to say negative 4 to infinity for the domain. Make sure that you include negative 4 since negative 4 at negative 1 is on the graph, right? We want to use negative 4 as our start point. And then the range is the y values. Okay, so if you scan the y-axis here, it looks like if we are at negative 1 or bigger on the y-axis and we look to the left or to the right, we're going to be on this curve here. If we are less than negative 1, there's no graph down here, right? That's less than negative 1. So I'm going to say negative 1 to infinity. And again, make sure that you include negative 1 here since negative 4, negative 1 is like my start point. Okay, so I want to make sure I'm including negative 1 when I start this scan of the y-axis. All right, that's all there is for section 11.1. So it's kind of intended that this was a review. Okay, like I said earlier, we've done things with functions, so we'll do a lot of things with functions in this chapter, actually. Be sure to look at the problems that are on page 860 for me.